simplifying rational expressions. So again, we are going to be taking a look at rational numbers to help us out with our understanding of rational expressions. So we are going to be writing rational expressions in lowest terms. So we're just going to say simplify. Now I'm just going to take a look at 7 over 35. Well, it may help if I prime factor. So let's get rid of prime factor. I'm just going to say factor both numerator and denominator. Well, the numerator is unable to factor. The denominator has two factors of 5 and 7. There we have it. So I'm going to put those in brackets. What we're able to see is that both numerator and denominator have a common factor of 7. So I can cancel that out. What is remaining is a factor of 1 in the top. Even though we crossed out 7, 1 remains. And the bottom, we have a factor of 5. So 7 over 35 can be simplified as 1/5. Now, similarly, I'm just going to the second example here, 6 over 27. I'm going to factor the top 6 is 2 times 3, and 27 is 3 times 3 times 3. Now, what I notice is both top and bottom share a common factor of 3, so I'm just going to cancel those out. And what is left over is 2 over 3 times 3, or 2 over 9 is what we would say with fractions. But I'm trying to encourage us to use our knowledge of fractions for rational expressions. So allow me to look at 16 over 20. What may be helpful is if I can spot out the greatest common factor, and that would be 4. So when I factor both top and bottom by a 4 out of them, what I recognize is that there's a common factor of 4, and you can cancel it out. So 16 over 20 simplifies to 4 over 5. So the process is I'm going to prime factor the numerator and denominator, and we can even get rid of the word prime, factor the numerator and denominator. We're going to cross out factors that are both common to the numerator and denominator. So it appears like I've done a whole bunch of work here. Let me just get rid of it. But before I do, we're going to factor the top, factor the bottom. And then let's see what we can do after that. Okay, might as well work through this because that's how we learn, by working through examples. So a rational expression is in its simplest form when the numerator and denominator have no common factors other than 1. So I guess we're getting pretty far into our factoring journey here for sure. We're going to simplify each expressions and state non-permissible values. So I'm going to factor the numerator. I'm going to factor the denominator. So I'm going to factor the denominator, and I'm sort of running into a dead end, and then all of a sudden I am not. I believe I did that incorrectly. I believe this is factored correctly now. Now, I'm just going to leave it up to us to assume that we can factor that. So there's a pretty big hint here because we share a common factor of x minus 2, just in case you're wondering. Did you factor it correctly? So chances are we have to share a common factor, both numerator and denominator. Once I factor, I'm going to list my non-permissible values. So x cannot be equal to negative 5 over 2 or 2. So now I have factored both top and bottom, numerator and denominator. I have listed my non-permissible values. Now I'm going to cross out common factors. So I'm crossing out those two common factors. What is left is 3 over 2x plus 5. And I'm just going to put a square around that to draw attention. Please don't forget my restrictions. So there we have it. Not so bad. Let me move on to the second one. Second example is 2x plus 4. So I'm going to factor that. So what I recognize is in the numerator, both terms have a factor of 2. So I'm going to cancel that out, and that would be x plus 2. I'm going to take a look at the denominator, and if you need to press pause to sort of get an extra practice on this, factor the denominator. So x squared plus 3x plus 2, what I recognize is that this is the product sum rule that I will be using, simply because the coefficient in front of the x squared is 1. What two numbers multiply to 2 but add to 3? Those. Next thing I'm going to do is I'm going to make sure that I list my non-permissible values. My non-permissible values are x cannot be equal to -2 or -1. At this moment, I'm going to cross out common factors. There we have it. So I have 2 over x plus 1. And just for fun, I'm just going to write x cannot be equal to -2 and -1. So just because you cross out a factor, that restriction remains. It's kind of important. Okay, this next one. This next one might be some new learning here, and it's kind of an important one. So I'm just going to write my rational expression, and we have it. I'm going to factor out both top and bottom, and I have a good feeling because the top feels like it's going to be a conjugate of the bottom. But I'm going to call this a near miss. So the bottom is actually a difference of squares, so I'm going to factor it into its two conjugates. I'm going to continue on my path of my restrictions or my non-permissible values, so t cannot be equal to -1 or 1. So what do I notice? I notice, isn't it curious, that these two factors are almost the same. So maybe I'm just going to reorganize this. So if I rearrange the top, the top is going to be looking like -t plus 1, and the denominator is going to be t minus 1, t plus 1. Let me put it in brackets. What we notice is that the two factors aren't identical. However, the numerator, if there is some magic way that we could take that -t and make it positive and change the sign also, not only on -t, but changing the sign on +1, then we could cancel it out a common factor. So what I'm going to do is, it's called the additive inverse. I'm just going to simply factor out -1, and that top factor becomes t minus 1. And the bottom factor is t minus 1 times t plus 1. I'm going to cross out my common factors of t minus 1. And what is left is -1 over t plus 1. So that's the additive inverse. And I'm not going to talk extensively about the additive inverse, but it's really, really handy. Sometimes when you're writing solutions and you look at a solution in the back of a book or comparing in a solution manual, and you'll notice that you're very close, but the signs have, or your expression has the opposite signs. Try factoring out -1 from an expression and see if it simplifies. A lot of times, many mistakes are the additive inverse.